Well, now the most interesting. The part that will be of interest to a wide audience is a demonstration of live migration and management of bhyve virtual machines on a pool-binded CBSD cluster. Just like a container, we can create virtual machines through the NuBect-L thin client. The same create commands, but instead of container, we write VM. All other commands, including status and SSH, are written as they are when working with containers. And all the same divisions into namespace based on the MD5 sum of your public key, which by default is convenient to use for different clients, but in a trusted environment. For public services, you must change the token algorithm. By the way, within the CBSD project, a new sub-project named Firestarter is announced, similarly and inspired by the Firecracker platform on the Amazon platform. This project is focused on running short-lived but very fast-running virtual machines based on BSD kernels and Linux. At the moment, the first virtual machine in our demo cluster is created, it works. It responds and it is visible in the dashboard. And now let's repeat the creation of the VM using curl and the JSON file beloved by all DevOps. Why do we need thin clients and graphical applications when a large number of DevOps are used to living in native YAML and JSON files? It was a little joke. The virtual machine on NVMe and SSD drive should be available within 10 to 15 seconds. Vanilla FreeBSD is very poorly optimized to run in parallel for services. You can easily compare this when you try to start a virtual machine from the Firestarter profile in the latest version of CBSD. Our cluster uses ordinary slow HDDs, so the availability of the SSH service lags a bit. In the first part of the demo, we talked about the importance of having a fully isolated CBSD working directory. That is, if you have multiple working directories, there may be some redundancy due to the same rootefs or ISO files. Why is it important? It has to do with live migration. Or rather, with checkpoints that give us the effect of live migration. When we freeze the checkpoint state of the VM and save the state to disk before exporting the pool, these files reflect the full state of the VM. For example, if the virtual machine at the time of the checkpoint opened the ISO image for use, we have an open descriptor for some file. Accordingly, when the machine wakes up from the checkpoint when importing the pool, this file must exist. Therefore, if we use resources outside the CBSD working directory, our live migration will fail. So let's start the virtual machine. Just in case, we redirect the VNC port to be on the safe side. We assume that the live migration will not reboot the virtual machine and will not affect the uptime and workflows inside the VM. But we assume that a small timeout when switching can break the SSH connection. So we start the IOStat process via SSH and in parallel. log in as local root via VNC and start another VMSTAT process so that we make sure that the VM will not be rebooted. If the machine does a cold boot, we will see that there are no users in it. So what do we see? The virtual machine made a checkpoint and the pool migrated to a new node, as it was with containers. This is zero copy, there is no copying and data migration. So it happens very fast. And we see that the processes have recovered and continue to work. Even the SSH session didn't end. Of course, a pool can have a large number of virtual machines.